All right, survivors, so you found yourself a sealed bunker. Congratulations, you're protected from raiders, radiation, and whatever else is trying to kill you out there. There's just one tiny problem. You're also sealed in with your own carbon dioxide, body odor, and whatever mold decided to move in before you did. Here's the thing, nobody tells you about post-apocalyptic survival. Clean air is just as important as clean water. You can last 3 weeks without food, 3 days without water, but only 3 minutes without air. And in a sealed space, that air gets real bad, real fast. We're talking headaches, dizziness, confusion, and eventually, well, let's just say you didn't survive the apocalypse just to suffocate in your own safe room. Today, I'm going to show you how to build a working ventilation and filtration system using nothing but scavenged junk. No fancy HVAC units, no industrial filters, just good old-fashioned wasteland engineering. And yes, things will go wrong. They always do. But that's how we learn, right? Let's get some air moving. Before we start duct taping fans to walls, we need to understand 3 basic concepts: airflow, filtration, and circulation. Airflow is simple. Air needs to come in, and air needs to go out. If you only have air coming in, you're creating positive pressure, and your room turns into a balloon. If you only have air going out, you create negative pressure, and you're basically vacuuming yourself. Neither is ideal. You want balanced flow, or slightly positive pressure, to keep contaminated air from sneaking in through cracks. Filtration is your second concern. Outside air might be full of dust, particles, spores, or worse. You need something between the outside and your lungs. Even basic cloth can filter out large particles. Layer it up, and you've got a surprisingly effective filter. Add some activated charcoal if you can find it, and you're filtering out gases and odors too. Circulation is the third piece. It's not enough to just move air in and out. You need to circulate it throughout your space so you don't end up with dead zones where carbon dioxide just sits there waiting to make you pass out. Think of your room like a pond, no movement. It gets stagnant real quick. Now, in an ideal world, you'd have an intake vent, an exhaust vent, a filter system, and a circulation fan. In the wasteland, you've got whatever you can scavenge. So let's work with that. First thing you need to do is survey your space. Walk around your bunker, closet, sealed room, whatever you're calling home. Look for any existing openings. Pipes that go outside, cracks in the walls, gaps under doors, old ventilation ducts. Even tiny cracks can work if you're creative. The key is to position your intake and exhaust on opposite sides of the room if possible. This creates cross-ventilation. Air comes on one side, travels across the space, and exits the other side. If they're right next to each other, you're just creating a shortcut, and most of your room never gets fresh air. Here's what I've gathered from various ruins and abandoned buildings. 2 battery-powered fans. A roll of duct tape, the most important tool in any apocalypse. Several pieces of cloth, old shirts, a torn curtain, some shop rags, a bag of charcoal from what used to be someone's grill. Cardboard boxes in various states of decay. Some metal sheeting from a destroyed air duct, plastic bottles, because they're everywhere, and a piece of PVC pipe I pulled out of a collapsed bathroom. Is this everything we need? Probably not. Will we make it work anyway? Absolutely. Let's start with the intake. This is where outside air comes in, so we need to filter it before it reaches our lungs. I'm taking this cardboard box and cutting out one side completely. This becomes my filter housing. Now I'm layering cloth inside it. First layer, this old t-shirt stretched tight across the opening. Second layer, these shop rags because they're thicker and will catch smaller particles. Third layer, I'm crushing this charcoal and wrapping it in another piece of cloth to create a charcoal layer. The charcoal is key for filtering out odors and some gases. It's not perfect, but it's better than nothing. Now I'm sealing the edges with duct tape, making sure air can only flow through the cloth layers, not around them. And finally, I'm positioning this filter box over my intake gap and securing it with duct tape. Again, if duct tape was currency in the apocalypse, I'd be a millionaire. All right, intake filter is in place. Air coming in from outside now has to pass through 3 layers of filtering before it enters our space. Good enough for government work. Well, if there was still a government, now we need to actually move air. That's where fans come in. I'm setting up this battery-powered fan right near the intake to help pull fresh air through the filter. Now we need exhaust. Air is coming in, but it needs somewhere to go, or we're just pressurizing this room until something pops. Remember that pipe I mentioned? That's our exhaust route. I'm going to put my second fan here to push air up and out through the pipe, positioning it at the base of the pipe, securing it with, you guessed it, more duct tape. Now here's the trick. I'm running the exhaust fan at a slightly lower speed than the intake fan. This creates slight positive pressure in the room, which means air wants to flow out rather than in. That helps prevent contaminated outside air from sneaking in through random cracks. Okay, we've got air coming in through the filter and air going out through the exhaust. But we need to make sure it's actually circulating through the whole space. I'm going to create a simple circulation system using these cardboard boxes and metal sheeting to direct airflow. Think of it like creating artificial walls that guide the air where we want it to go. I'm building this tunnel from the intake across the room using boxes and metal scraps. This forces the incoming air to travel along a specific path before it can escape through the exhaust. And then I'll add a small fan here in the middle to keep things moving. Now that we have basic airflow working, let's improve our filtration. The filter I built is catching large particles, but we can do better. I'm going to create a multi-stage filter box using these plastic bottles. I'm cutting them in half, stacking them to create chambers, and filling each chamber with different filtering materials. First chamber, coarse cloth to catch big particles. Second chamber, finer cloth for smaller particles. Third chamber, crushed charcoal wrapped in cloth for odors and gases. Fourth chamber, one more fine cloth layer as final filtration. I'm connecting these chambers with short sections of PVC pipe, creating a path the air has to travel through. Each stage removes progressively smaller contaminants, sealing everything with, take a guess, duct tape, and integrating this superfilter into my intake system. This is actually looking professional now. Well, professional by wasteland standards. It's like something you'd see in a survival manual if that manual was written by someone who'd been huffing too much adhesive. I'm taking this large plastic storage container and converting it into a ventilation powerhouse, cutting an intake hole here, an exhaust hole there, mounting a fan on top, installing the multi-stage filter on the intake side, and adding circulation ports on the sides. This single box will handle intake, filtration, and circulation all in one unit. It's compact, it's efficient, and it's entirely made from garbage. Beautiful. So, how do we know this is actually working? There are a few simple tests. First, the paper test. I'm holding a piece of paper near the intake. If there's negative pressure pulling air in, the paper should be pulled toward it. And yes, the paper is definitely being drawn toward the intake. We have suction. Now testing the exhaust. Holding paper near it, and the paper is being pushed away. We have positive airflow out. The system is balanced. Second test, the smell test. When I first entered this room, it smelled like old concrete and regret. Now it smells like, well, it still smells like concrete, but fresher concrete, outdoor concrete. That's progress. Third test, visual inspection of the filter. Remove the filter box and check the cloth layers. After just 20 minutes of running, look at this. The outer layer is already visibly dirty. It's caught dust, particles, and who knows what else. The inner layers are cleaner, which means the multi-stage filtering is working exactly as designed. And finally, the most important test. How do I feel? My headache from earlier, gone. My breathing, easier. My confidence in my ability to survive in a sealed room, significantly improved. This system works. Let me give you a final explanation of the complete system. Air enters through the intake vent, pulling from outside through that crack I widened. It passes through the multi-stage filter box, removing particles and odors. The intake fan pulls the filtered air into the room, creating a slight positive pressure. The air circulates through the space, pushed along by the circulation fan and guided by the cardboard and metal ductwork. Finally, air exits through the exhaust pipe, pushed up and out by the exhaust fan. The cycle continues, constantly replacing stale air with filtered fresh air. Total cost, 0 bottle caps. Because I scavenged everything. Total time, about 2 hours, including mistakes. Total effectiveness, surprisingly high for a system built from garbage. You could survive in this room indefinitely now, at least from an air quality perspective. You'll still need to deal with food, water, and existential dread, but at least you won't suffocate. All right, survivors, let's recap. Clean air in a sealed space requires 3 things: intake with filtration, exhaust for air to escape, and circulation to prevent dead zones. You can build all of this with scavenged materials if you understand the basic principles. Will your system be perfect? No. Will things go wrong? Absolutely. Will you blow dust in your face and create accidental wind tunnels? Probably, but that's fine. Adjust, improve, and keep that air moving. See survivors. This is wasteland engineering. Nothing works perfectly. Everything breaks eventually, and you just keep adapting. As long as you understand the principles, you can rebuild, repair, and keep yourself alive. Stay breathing out there, and I'll see you in the next video where we tackle something slightly less likely to suffocate us. Probably no promises.